In today's interconnected world, data security is paramount. As information traverses networks, it becomes vulnerable to interception and compromise. IPsec, short for Internet Protocol Security, emerges as a robust framework designed to safeguard network communications. Operating at the network layer, IPsec provides a comprehensive suite of security services, ensuring data confidentiality, integrity, and authenticity. IPsec's strength lies in its ability to secure communications at the IP packet level. This granular approach allows for the protection of individual data packets, rather than relying on higher-level protocols. By encrypting and authenticating each packet, IPsec effectively shields sensitive information from unauthorized access and modification. This makes IPsec an ideal solution for securing various types of network traffic, including sensitive data transfers, financial transactions, and remote access connections. The importance of IPsec in contemporary network security cannot be overstated. With the rise of cyber threats and data breaches, organizations and individuals alike require robust mechanisms to protect their valuable information. IPsec's comprehensive security features and flexible deployment options make it an indispensable tool in the fight against cybercrime. By implementing IPsec, organizations can establish secure communication channels, ensuring the confidentiality and integrity of their data. Whether it's securing virtual private networks, VPNs, or protecting sensitive data exchanges between corporate networks, IPsec plays a vital role in safeguarding our digital interactions. Its widespread adoption and proven track record underscore its significance in today's interconnected world. As we continue to rely on networks for communication, collaboration, and commerce, IPsec will remain an essential component of a comprehensive security strategy. At the heart of IPsec lie several key mechanisms that work in concert to provide robust security. Security associations, SAs, Authentication Header, AH, and Encapsulating Security Payload, ESP, form the cornerstones of this framework, each contributing unique functionalities to the overall security posture. Security associations, SAs, serve as the foundation of IPsec, establishing a shared security context between communicating devices. Think of SAs as agreements between two parties on how they will secure their communication. These agreements define various security parameters, including encryption algorithms, authentication methods, and keying material. Each SA is uniquely identified by a combination of factors, ensuring that only authorized parties can participate in the secure communication. Authentication Header, AH, provides data integrity and origin authentication, ensuring that data packets haven't been tampered with during transmission. It achieves this by attaching a cryptographic signature to the IP header, verifying both the data's integrity and its source. This signature, generated using a shared secret key, allows the receiver to validate the authenticity of the packet and detect any unauthorized modifications. Encapsulating Security Payload, ESP, as its name suggests, focuses on data confidentiality. It encrypts the entire IP packet, including the original header and payload, rendering the contents unintelligible to unauthorized entities. By encrypting the data, ESP ensures that even if intercepted, the information remains protected from prying eyes. This is crucial for safeguarding sensitive data, such as financial transactions or personal information. IPsec offers two primary modes of operation: tunnel mode and transport mode. These modes provide flexibility in deploying IPsec, allowing administrators to tailor the security implementation to specific network requirements. Understanding the nuances of each mode is crucial for effectively leveraging IPsec's capabilities. Tunnel mode operates by encapsulating the entire original IP packet within a new IP header. This mode is particularly useful for creating secure connections between networks such as VPNs. In tunnel mode, the original IP packet, including the header and payload, is encrypted and authenticated. A new IP header is then added, effectively creating a secure tunnel between two endpoints. This tunnel protects the data as it traverses untrusted networks, ensuring confidentiality and integrity. Transport mode, in contrast to tunnel mode, only secures the payload of the IP packet, leaving the original header untouched. This mode is suitable for securing communications between individual hosts, where the IP header information is not considered sensitive. By focusing on payload protection, transport mode reduces overhead and improves performance, making it suitable for scenarios where latency is a concern. The choice between tunnel mode and transport mode depends on the specific security requirements and network architecture. Tunnel mode is ideal for securing communications between networks or creating VPNs, while transport mode is more appropriate for protecting data exchanges between individual hosts. Understanding the strengths and limitations of each mode allows administrators to implement IPsec effectively and tailor the security posture to their specific needs. IPsec's versatility and robust security features make it a popular choice for a wide range of real-world applications. From securing virtual private networks, VPNs, to protecting sensitive data exchanges between network devices, IPsec plays a crucial role in safeguarding our digital interactions. Let's explore some practical examples of IPsec in action. VPNs rely heavily on IPsec to establish secure connections between remote users and private networks. When a user connects to a VPN, IPsec creates an encrypted tunnel between the user's device and the VPN server. This tunnel protects all data transmitted between the two endpoints, ensuring confidentiality and integrity. This is essential for remote workers, allowing them to securely access corporate resources from anywhere with an internet connection. IPsec also finds extensive use in securing communications between network devices, such as routers and firewalls. By implementing IPsec, organizations can protect sensitive data exchanged between these devices, preventing unauthorized access and modification. For instance, IPsec can secure the routing protocols used to exchange routing information between routers, ensuring the integrity of the routing tables and preventing routing attacks. Beyond VPNs and network device communication, IPsec also plays a vital role in securing various other types of network traffic. For example, IPsec can secure voice over IP (VoIP) calls, protecting sensitive voice conversations from eavesdropping. It can also secure financial transactions, ensuring that credit card information and other sensitive data remain confidential during online purchases. These are just a few examples of how IPsec is used in practice to protect our digital lives.